Hey guys, what's going on? Today we're going to be looking at 13.2, permutations and combinations. So 13.1 we looked at sample spaces, which was the amount of outcomes that could happen in a given situation. So for permutations and combinations, we're basically concerned about the arrangement of a certain amount of objects. Okay? Permutations and combinations are very similar. Like when you look at the equation here, these two equations, even when you look at the equations, they are very similar yet different. And there's one key thing that will change the situation from being a permutation versus a combination. And that key thing is ordering. So a permutation is an ordering or an arrangement of objects where order matters. Okay, some classic examples of when order would matter is when you're concerned about runners finishing a race. Okay, order would matter because if you're assuming no ties, only one person can get first place. And then after that, you have a set amount of people that could get second, third, so on and so forth. So ordering would matter. Digits in the code, phone number, or student ID, order would also matter there. And arrangement of letters. So a combination, so vice versa, in a combination, order does not matter. Okay, so members chosen for a committee, job, game, or club. If you're, say, you're hiring people to be on a committee, okay, it doesn't matter per se in what order you're going to hire those people, okay, or some like selecting colors to color with. That would also be an example of uh, an arrangement of things, colors in particular, in which the order does not matter. It does not matter if you have a box of crayons and you grab a red. That's not really going to affect too much the next color you choose if it's blue. It doesn't matter that you chose red first and blue second. It doesn't really make a difference. Okay, so for permutations, as you see the rule here, we have P n comma r equals n factorial over n minus r factorial, which FYI, this exclamation mark here, since the notes don't say it, this exclamation mark here, that's called a factorial. Okay, a factorial is a type of operation, just like multiplication, division, addition, subtraction, those are all operations. Factorials are also operations. Okay, a factorial is a specific type of operation. So we have n and r. So n on both of these is going to represent the total number of things in your list or set, and r is the selected amount, so the amount you're kind of focusing on. And that's going to be the same on both. Okay, now before I get into the actual notes, okay, I just want to talk a little bit more about factorials and what they are and what they look like. So factorials is really kind of a specific type of multiplication, and it's actually a direct consequence for permutations and combinations. The reason why factorials pop up is it is actually a direct consequence of your fundamental counting principle that we went over in 13.1. So first, for a factorial, here's what a factorial looks like. So say I had 4 exclamation mark, which again, that's factorial. Okay, the way you would compute that is you would say 4 times 3 times 2 times 1. Okay, 4 times 3 is 12, times 2 is 24. Okay, and then clearly multiplying by 1 does not affect the value. So similarly, 3 factorial would be 3 times 2 times 1. So 3 times 2 times 1 is 6. So for a factorial, okay, You're starting at that number and multiplying by every number that's behind it, okay? Every number that precedes it, you're multiplying by it. So also you can only take factorials of whole numbers, whole positive numbers. So 1, 2, 3, 4, 5, 6, 7, 8, all the way up to whatever large number you want. But it's essentially a large counting number. It's the only things you can take factorials of. Okay. The reason why these pop up with stuff like permutations and combinations is directly because it's a consequence of the fundamental counting principle. Say, for example, I said I had 4 runners finishing a race. How many ways could they finish? Okay, so I got 4 runners, and I know by fundamental counting principles, I'm going to end up multiplying these guys together. So for first place, okay, so for first place, well, I have 4 potential runners that could get first place. So 4. Then for second place, again, if we're assuming no ties, well, one person already finished the race. So now I have 3 other people that could potentially get second, then 2 for third, and then one person would be left for fourth place. So again, that's just 4 factorial. 4 times 3 times 2 times 1 is 24. Now let's take the same situation. Say I changed it to 5 runners. And say now that I only care about if they get first, second, and third place. First, second, and third place. So there is 5 runners, but now I only care about first, second, and third place. Okay, so now, again, for first place, I have 5 potential runners that could get first place, then 4 for second, and then 3 for third. So 5 times 4 times 3 goes to 60. Okay, so that's kind of how factorials work and why they are in your equation for permutations and combinations. Now, we realistically will just have you put it in the calculator with menu 5, the menu 5 command in your calculator. So on these questions, the first key step is identify if it is a permutation or combination, then identify your N, your total amount of things, and then R, your selected amount. Okay, so let's take a look at example 5. In how many ways could 9 snowboarders finish a race? Okay, so we're talking about a race, so order matters, so it's a permutation. Your total amount of runners is 9. And on this one, it might be a little tricky for a very first example, but the amount of things within those 9 racers you're wanting to arrange in this case is also 9 because it's asking how many ways could all 9 of them finish. So it's not asking specifically for first, second, and third place, so on and so forth. So this is a permutation with N being 9 and R being 9. Okay, so in your calculator, you'll hit menu 5. It'll open up a menu and you'll see factorial, permutation, and combination. Permutation, I believe, is option 2. So you hit 2, and it pops this up in PR parenthesis. So then you put in first, which is 9, and then comma. The comma is right below your pi button in your calculator. And then you hit 9, close your parentheses, hit enter, and it'll spit out the answer for you. Okay, so if you do that, it gives you 362,880. So that's the amount of ways 9 racers could finish a race. Okay, so it's a big number, but it's fairly normal when dealing with factorials to have really big numbers. Um, Factorials are actually the third fastest growing type of function in all of mathematics. There's only two types of functions that grow faster than a factorial. So it's fairly normal to have some large numbers when you're dealing with factorials. Okay, moving on to example 6. Okay, in how many ways can 6 letters be chosen from 26? Okay, this one's slightly tricky, but order actually does not matter here, so it's a combination. Now, the way this was written, it almost could have been a permutation. If it had said that letters cannot be repeated or something of that nature, then order would matter a little bit. Um, but they didn't specify that. So really, you also could have repeats of letters when you're choosing. So that makes this a combination. Okay, order does not matter in this case. And in your total amount of letters you're picking from is 26. And then the selected amount that we're looking at is 6. So that's C 26 comma 6. So again, you go to menu 5, and then now you hit 3 after that to get to your combination, and it'll pop up in CR. So note that difference there to know if you've opened up the right one. Then you'll put 26 comma 6, hit enter, and it'll tell you the answer. So if you do that, it should give you 230 comma 230. Okay, and another hint. If you see the word chosen, okay, in your situation, it's going to be a combination. Now, that's not to say that you couldn't have, that the word chosen couldn't be there and it could still be a combination. That could very well happen. But if you see the word chosen, then it's a combination. Okay, for 7, there are 6 runners in a race. How many ways could 3 runners finish in first, second, and third place to win? Okay, this is a race. Classic example of ordering matter. It's a permutation. Your total amount of runners in is 6. Now the amount of places we're concerned about is just 3. So this is P 6 comma 3. Okay, so again, you put it in your calculator, menu 5, all that good stuff. And then 6 comma 3, hit enter, and that'll give you 120. Now again, kind of like when I talked about it before, if you try to do it by hand, again, you're concerned about first, second, and third place. 6 runners could get first, and again, we're assuming no ties. So then after that, you have 5 people for second place and 4 people for third place. You do 6 times 5 times 4. Again, that's 120. But your calculator will do all the legwork for you. For 8, in how many ways can the letters orange be arranged? Okay, so we're talking about letters being arranged in a specific word. So order would matter. So this is a permutation. In is 6. There are 6 letters in the word orange. And R, well, we're rearranging all the letters. So 6. So we got P 6 comma 6. Okay. So again, if you do it in your calculator, and put P 6 comma 6, that'll give you 720. Okay, and that is it, guys. Thank you.